What would our civilization be in a Type 1 Kardashev scale? The Kardashev scale is a method used to determine a civilization's technological advancement, which divides civilizations into three types, with Type 1 being the simplest civilization of all. The civilization created by the human race is not yet advanced enough to be considered a Type 1 civilization. How long until we reach that classification? Stay tuned to find out. Astrophysicist Nikolai Kardashev developed the Kardashev scale in 1964 to determine some characteristics that would facilitate the search for extraterrestrial life. After analyzing several conditions in the history of the human race, Kardashev realized that there is a need that grows as civilization does: energy. As the human race has expanded worldwide, so are the needs for energy. Suppose this is inherent in all species that become an intelligent race. In that case, a hypothetical race of aliens who come to forge a civilization as significant or more extensive than that of humans will eventually also have an energy deficit. To solve this energy need, an extraterrestrial race must develop technologies to meet the demand for energy needed to sustain all members of their civilization. Kardashev theorized that in this sense, there must be three types of civilizations. Type 1, a civilization that can harness all the energy its home planet gives them. Type 2, a civilization that can harness the energy of its entire solar system. Type 3, a civilization that can harness all the energy provided by the galaxy it is in. This series of videos will talk about each of these civilizations, and today we will talk about the Type 1 civilization. Type 1 civilization on the Kardashev scale. A Type 1 civilization has managed to create the technology to take advantage of every last drop of energy that its planet produces and the energy it receives from its star. Currently, if we count all the existing methods of electricity generation such as wind energy, geothermal, osmotic, wave, tidal, hydraulic, and of course solar energy, the planet Earth is capable of providing between 10 to the power of 16 and 10 to the power of 17 watts of energy to humanity. However, of that total, we only take advantage of 0.7%. That is why currently the human race cannot yet be classified as a Type 1 civilization. Human civilization is found in Type 0 civilization, that is, one that has not yet learned to harness the total energy of its planet. But how long until human civilization reaches the rank of Type 1 on the Kardashev scale? To find out, first let's talk about what a Type 1 civilization would be capable of. Fusion energy. At present, fusion energy is still far from becoming a reality. However, some experts are taking essential steps to creating, such as the International Thermonuclear Experimental Reactor, ITER in France. This consists of a magnetic fusion device designed to demonstrate the viability of fusion as a large-scale, carbon-free energy source, based on the same principle by which the sun and stars generate their energy. Nuclear fusion is a phenomenon in which two atoms fuse by the pressure of gravity or any other force. During the process, two or more atoms combine to create a single heavier one, and as a byproduct of that fusion, an immense amount of energy is generated. This is how stars work. The sun, the central star of our solar system, fuses hydrogen atoms into helium atoms. That process has been working for billions of years, giving the sun almost unlimited energy. If we can replicate that process on Earth, we should have the sun's power in the palm of our hands. Unfortunately, all nuclear fusion reactors are in the testing phase. Although the first lights are already being seen in creating this type of energy, there is still a long way to go before making this a reliable method to provide energy to humanity. A Type 1 civilization on the Kardashev scale would have access to nuclear fusion energy, and much of the world's demand would be supplied with it, which would serve to meet the needs of all members of its population and much more. Antimatter. Antimatter is the opposite version of matter as we know it. It comprises particles with an opposite charge to those that make up ordinary matter, and it is the most challenging material for humanity to obtain today. The most important thing about antimatter is that when it comes into contact with ordinary matter, are self-destructing, and in the process release a lot of energy. If we find a way to control large amounts of antimatter in the future, they could be an essential source of energy. There are two ways to get antimatter. On the one hand, we have particle accelerators, and on the other hand, there are the Van Allen belts. In Geneva, Switzerland, there is the Large Hadron Collider, better known as the LHC. This is the biggest machine built by humanity to date. The LHC is formed by a series of equipment and laboratories connected to a circular tunnel with a circumference of 26.7 kilometers. In this tunnel, the scientists are responsible for injecting R subatomic particles at speeds close to light. They are made to collide so that they release, among other things, antimatter particles, which we can only see but not collect. To collect antimatter, we would need to have a chamber with magnetic walls that retain the particles in a confined space without touching the walls. Remember that it explodes if the antimatter comes into contact with matter. But even if we manage to retain antimatter in a confined space, there is a problem. This problem is that although the LHC has been in operation since 2009, it has not been possible to produce a single gram of antimatter. This is because nanograms count the amount of antimatter produced in each collision. At that rate, it would take us several million years to make 1 gram. We don't have that much time, so if the human race wants to harness the energy of antimatter in the future, we will have to build giant particle accelerators or opt for option 2. Van Allen belts are donut-shaped regions around the Earth where there are high rates of ionizing radiation caused by the Earth's magnetic fields. Ionizing radiation is highly energetic radiation capable of ionizing matter, that is, of breaking molecular bonds and, in some cases, breaking atomic bonds. In the Van Allen belts, there is a special zone called South Atlantic Anomaly. In this section of the Van Allen belts, the radiation is substantially higher than in the rest of the rings, so astronauts are prohibited from passing through those areas when they perform space flights, since doing so would put their lives at risk. In 2011, the Satellite for Antimatter Exploration in Light Core Astrophysics Studies, better known as PAMELA, showed that this region can trap antiprotons, a type of antimatter particle produced by the shock of highly energetic particles from the Sun. Scientists believe that the amount of antimatter in the South Atlantic Anomaly could be enough to implement a project that allows the antiparticle to be used as fuel to propel spacecraft on future trips to other planets. The humanity already possesses this knowledge even without being an advanced civilization. In that case, it means that a Type 1 civilization on the Kardashev scale should be able to harness antimatter at will, produce it in large quantities, and use it for the purposes that suit it best, from supplying energy for cities to fuel for spacecraft or even for land vehicles. As we mentioned in a previous video, antimatter is the best fuel when you want to make trips in space, as it is super light, efficient, and provides truly incredible amounts of energy. Renewable energies. One of the most remarkable aspects of the modern era is the goal of getting closer and closer to renewable and environmentally friendly forms of energy generation, and leaving behind the energy from fossil fuels that pollute the world so much. This means that as it advances, an intelligent civilization is increasingly distancing itself from fossil fuels and opting for renewable energy. Currently, human civilization has developed technologies that allow energy to be obtained from almost all natural phenomena. To take advantage of the energy of water, we have developed hydroelectric, tidal, wave, and osmotic energy. For wind, we developed wind energy. To take advantage of the energy coming from the Earth's interior, we created geothermal energy. We created photovoltaic energy systems and solar thermal energy for energy from the sun. And we even developed methods of power generation that do not exist on the planet, such as fission and nuclear fusion. All of these methods are just beginning to gain traction worldwide, but methods of generating power from fossil fuels such as coal and oil still far outweigh all renewable energy methods. A Type 1 civilization on the Kardashev scale would not depend on fossil fuels. On the contrary, all its energy production would be 100% based on renewable energies. They would take advantage of absolutely all the natural phenomena of the Earth. They would even be able to take advantage of the energy of meteorological phenomena that for now are unimaginable for us, such as taking advantage of the energy of lightning, the energy of hurricanes, and even the energy of volcanic eruptions and earthquakes. Climate control. A Type 1 civilization could do things that for now the human race are a mere dream. One of them is to control the climate completely. There are already some attempts to control the weather. such as the artificial rains created by the United Arab Emirates using drones that stimulate the water droplets suspended in the atmosphere to gather and fall by their weight in the form of rain. While this technology can create rain, this only changes the weather for a very short period of time, but the weather in general remains the same. A Type 1 civilization could do just that, change the climate anywhere in the world at will. It could cause rain in deserts, snow to fall in tropical cities, or heat at the poles of the planet. This is not to say that they would put their very existence at risk, only that they would have complete control of their planet's climate for their benefit, such as making it rain so that crops grow, making it hot so that people do not die of cold, or make it colder to freeze and preserve food. Having complete control over the climate would also entail a great responsibility on their planet that they will surely know how to cope with so as not to self-destruct. Shaping the world as you please. A Type 1 civilization would not only be able to control the climate of their planet, but they would also be able to control the entire planet at will. They would have the technology to trigger rain, hurricanes, tornadoes, tropical storms, earthquakes, tsunamis, and even volcanic eruptions. They would go from being just another species on the planet to being the absolute masters and rulers of the world. They would assume total control of what can happen, move cities, mountains, and even entire continents, giving the world the shape they want. They could place cities in the areas with the best climate or make the whole planet have the same environment everywhere. If we compare them to our current civilization, they would be like gods who could do anything they wanted with the planet. Permanent stay in space. Of course, a civilization with these characteristics would have the possibility to leave its planet when and however it wanted to. Although currently the human race already has a home where there are humans constantly in space, the International Space Station, a Type 1 civilization would not have only a few astronauts in space around its planet. It would have entire cities orbiting close to its planet, possibly in artificial ring-like structures around the planet where humans were living permanently in space. As you can see, a Type 1 civilization on the Kardashev scale is not just about how much energy is produced, but what can be done with all that energy. At present, the human race is only on 0.76% of the Kardashev scale. When do you think we could get to do everything a Type 1 civilization can? According to scientist Michio Kaku, at the rate at which humanity is progressing, humanity could become a Type 1 civilization in about 100 or 200 years. That is clear if we do not kill ourselves in a senseless war or a deadly virus exterminates us. If we survive, let's hope that one day, with the effort of all the members that make up this society, we will be able to move forward and together build the civilization of the future. Type 2 civilization on the Kardashev scale, able to control a star. In the studies to determine how much energy a civilization much more advanced than ours would require, a measure called the Kardashev scale emerges. It establishes the capability that each type of civilization could have. In this way, a Type 1 civilization could harness all the energy of its planet, while a Type 2 civilization could harness all the power of a star. But what technologies would they need to do this? Energy. All types of civilization proposed by Kardashev are based on the energy need of each civilization. This energy is measured in watts. Currently, human civilization has an energy need of 175,249 terawatts per hour, representing 0.73% on the Kardashev scale. That is, humanity's energy need does not yet reach the requirement that a Type 1 civilization would have. Energy need of a Type 2 civilization. When a Type 1 civilization has managed to completely control its planet and meet the energy needs of all of its inhabitants, it will proceed to expand throughout its star system. This includes colonizing the planets closest to their home planet, terraforming both planets and natural satellites, and harnessing minerals from asteroids and comets with space mining, a process similar to the mining we do on Earth but carried to bodies beyond the planet. A Type 2 civilization would use the same energy harvesting techniques to exploit the resources of all available planets and gradually send spacecrafts to explore stars near their star system and take advantage of the resources and minerals of other star systems. As a Type 2 civilization began to expand throughout its star system and nearby star systems, the lack of energy to move over such great distances would also become apparent. But above all, they would need energy to power spaceships, machines that are responsible for terraforming neighboring planets, robots, artificial intelligence, supercomputers, and of course to supply the needs of all members of civilization. According to Kardashev, this energy would need to be at least 10 to the power of 26 watts. That is an energetic quantity that could not be covered or by taking advantage of the energy of all the planets combined. The only way to meet the demand for so much power would be direct with a star. Assuming a civilization living in a star system with a single star like us, a star the size of the Sun would be enough to supply this energy for several billion years. For this, they would have to create one of the most famous structures in the fictional world. Dyson Sphere. The Dyson Sphere is a hypothetical megastructure that would be able to surround a star to harness its energy. This was first theorized by science fiction writer Olaf Stapledon in his novel Star Maker from 1937, in which he described every solar system in the galaxy would be surrounded by a gauze of light traps that focuses on the solar energy that escaped to be used by the intelligent. This concept was later popularized by Freeman Dyson, an English mathematical physicist famous for searching for extraterrestrial life. Dyson theorized that the structures devised by Stapleton could be physically possible, and if they exist, could be an excellent way to detect the existence of intelligent civilizations in our universe, since such a structure would emit a peculiar form of infrared radiation that no other body in the universe can emit. As Stapleton did not give any name to the megastructures of his novel, the widespread public began to call them Dyson's Sphere, believing that it had been Freeman Dyson who had invented them. A Type 2 civilization would have the skills, knowledge, and above all, the need to create this megastructure around its star to make the most of its energy. Although the exact shape that this structure could have has not been proposed, it is known that it should only partially cover the entire star, since if it is completely covered, the whole star system will cool down, putting at risk the colonies of the terraformed planets. In this way, a Dyson Sphere would have the shape of a spherical cage made by gigantic mobile structures much larger than a planet that would be in constant rotation at a very close distance from the star, capturing all the radiation and storing the energy to be used later for the purposes that civilization wants. This energy will likely be stored by small spacecraft coupled to the Dyson Sphere. Once filled with maximum energy capacity, they will be separated from the structure to carry this energy to the farthest regions of the solar system where the star's light is dim. A civilization that wanted to build this megastructure would have to take a space mining process to an unprecedented scale. They would have to move vast amounts of matter since the materials of a single planet would be insufficient to build the structure. They would have to take advantage of all the materials provided by the asteroid belts farthest from the solar system and carry chunks of minerals and rocks from the outskirts of the star system to the center, which would require immense numbers of workers, robots to help workers, and of course an enormous amount of energy. Another way to take advantage of it would be to use it to build more parts of the structure and make it bigger and bigger so that the Type 2 civilization would develop mainly around the star. And once reached some control over that energy, they would proceed to do things that for now are unimaginable to us. Among some of those things are: 1. Starlifting. A Type 2 civilization on the Kardashev scale that has built a Dyson Sphere around its star would be able to literally tear off a piece of its principal star and take it elsewhere. Although it sounds strange, this procedure happens naturally in the universe. When two stars get too close, the gravitational attraction begins to tear pieces of the other until in the end, one of the stars is left with almost all the matter of both. During this process, the chunks of one star are absorbed by the other, and the star from which the matter is being ripped out is eventually left with the core exposed, while the other star further gains mass and becomes much more significant. A civilization that had complete control over its star could do this. Tear off a piece of its star and take it to the farthest areas of the solar system for its purposes, such as powering an asteroid mine in the most distant region of the star system or moving large bodies with the strong gravitational pull that the piece of a star has. 2. Efficient transport. One of the applications that could have to place a Dyson Sphere and efficient energy use would be to produce antimatter on a large scale. Currently, humanity is already capable of producing antimatter, but with our current technology, it would take hundreds of billions of years to make a single kilogram. A Type 2 civilization could take advantage of starlifting for antimatter production. when tearing off pieces of its star, immense amounts of energy would be used. This same energy would have as a byproduct of antimatter. As we mentioned in a previous video about the different ways aliens could reach Earth, one of the most efficient fuels for traveling the universe is antimatter. This would be the perfect fuel for a Type 2 civilization that wants to transport large amounts of energy and materials throughout the solar system quickly and efficiently, since other fuels such as chemicals would not provide enough thrust to quickly move throughout the star system. Antimatter would serve to power their spacecraft and provide sufficient energy to the machines and supercomputers responsible for all the terraforming processes of other planets. And in other more apparent instances, antimatter would provide a source of energy for those areas too far from the star, areas that would usually be too cold. 3. Move planets. Although for now, human civilization is not even capable of moving asteroids, a Type 2 civilization would have the power to move asteroids, comets, and even planets. With the full harnessing of their star's energy and star lifting to tear off pieces of their star, they would also have control over huge gravitational pull fields. Recall that the force of gravitational attraction is directly proportional to the amount of matter. A civilization capable of making a megastructure around a star would have the ability to move immense bodies the size of planets using gravitational attraction. In this way, they could place all the planets of their solar system in the star's system's habitable zone, so that they can all host life and thus meet the demand for space for all individuals of civilization. They can also place gaseous planets away from habitable zones to shield asteroids that might shoot out due to space mining. Or they could even collide asteroids on very cold planets to warm them faster, dock them with a couple of natural satellites, among many other things a Type 2 civilization could do with the planets in its solar system whatever it wanted. And in a larger scenario, they would be able to place all the planets in their star system in a tiny region to surround their main planet, creating a kind of shield made of planets to protect the home planet. 4. Moving the entire solar system. But the thing does not stop there. A Type 2 civilization on the Kardashev scale could move entire planets and advance the solar system as a whole and take it elsewhere. By fully controlling the energy and gravity of its main star, this civilization could shape its star system and change the path it moves around the galaxy it is in. This way, they would not need to move to other star systems with spacecraft, as the entire star system would be their spacecraft. This shows us that a Type 2 civilization goes far beyond what a Type 1 civilization could even imagine. While a Type 1 civilization could move continents, a Type 2 civilization could move planets. While a Type 1 civilization could change the direction of its planet, a Type 2 civilization could change the direction of the entire star system. Multiple wake systems. So far, we have talked about a scenario in which a Type 2 civilization could harness the energy of a single star, but in the universe, most systems have more than one star. Let's take as an example the star system closest to us, Alpha Centauri. This star system contains 3 stars. Although 2 of them are smaller than the Sun, together the 3 have much more mass than the Sun. A civilization developing in a star system with more than one star could do everything mentioned above, but multiply by 2 or 3 stars. For now, there is no evidence that there is a civilization with these characteristics in our galaxy or the observable universe. Still, it would be a civilization worthy of fear if it existed without a doubt. Being capable of moving planets and repositioning stars is the closest thing to gods we can imagine. But even a Type 2 civilization is small compared to a Type 3 civilization that would be able to move a solar system and move an entire galaxy. Kardashev Scale Type 3 civilization. Beings with the power of gods. Technology of a Type 3 civilization. A Type 3 civilization would have technologies very similar to a Type 2 civilization, but taken to a galactic scale. Of course, they would also have completely new technologies that for now only exist in theory. Some of these technologies include use of supermassive black holes. Black holes are huge, massive bodies with a large amount of compacted mass in a tiny space. These are the product of the death of a star at least 10 times larger than the Sun and can absorb everything close to them. Black holes have so much mass that they warp the space around them. Plus, they can absorb other black holes to get bigger and become supermassive black holes over time. Supermassive black holes are the densest bodies in the universe. Spiral galaxies like the Milky Way have supermassive black holes at their center, which can have billions of times the mass of the Sun. In 1974, the physicist Stephen Hawking theorized that the black holes produce radiation. This radiation was called the Hawking radiation. A Type 3 civilization on the Kardashev scale could build massive structures similar to Dyson spheres, but billions of times more significant, to take advantage of this radiation emitted by black holes, and could even take advantage of the space-time deformation that exists in the vortices of a black hole to travel into the future due to time dilation. Use of quasars. Quasars are the most luminous objects in the known universe. They consist of galaxies in which the central supermassive black hole has begun to absorb everything within its reach, and the matter that makes up the galaxy starts to form part of the black hole's accretion disk. Due to this, a massive amount of energy is produced, released in the form of radio, infrared, light, ultraviolet, and X-ray waves. When a civilization reaches Kardashev Scale 3, it could build a vast structure capable of harnessing the immense amount of energy a quasar produces. The structure they would use would be very similar to that used in a black hole. Still, for now, such technology is not possible to theorize for humans, since it does not exist. Or rather, no known material can resist the deformation caused by space-time. Of course, in addition to the technology to take advantage of these astronomical bodies, a Type 3 civilization would also have smaller-scale technologies that they would use to expand their civilization to the last corners of the galaxy. Evolution. Currently, humans are the only species known to create artificial organisms that serve us and help us fulfill our tasks more easily and quickly. Robots. Already for decades, fiction writers such as Isaac Asimov began to worry about the hasty advance of machines. This concern is perfectly reflected in his novel, I'm a Robot, where robots became aware of themselves and threatened the human race. Nowadays, computer technology and artificial intelligence that serves to control machines are advancing by leaps and bounds. In less than 50 years, we went from performing a few mathematical calculations to creating machines with human appearance and voices that imitate our expressions and are capable of learning. If things continue like this, the technology, we believe, will likely surpass us in intelligence sooner or later. The artificial organisms we have created evolve much faster than biological organisms. Biological evolution has made us human, but artificial evolution is much faster. In this scenario, a civilization that has expanded through the galaxy would see the disadvantage of being living organisms, since they would be limited by slow biological evolution. On the other hand, the machines and artificial intelligence that they created will evolve faster and better than them until they eventually surpass them in all aspects. To avoid this, a Type 3 civilization on the Kardashev scale must set aside biological evolution and become artificial beings, passing their mind and consciousness to artificial devices created by themselves. The members of this civilization would be utterly different from what we know. They would be neither biological nor artificial. They would be a mixture of both. In this way, technology would not surpass them, and they could live forever. In other words, the members of a Type 3 civilization on the Kardashev scale would be immortal beings. However, there is a second possibility, in which, as the Type 3 civilization expands through the galaxy, it will run into other extraterrestrial races that would also become part of its civilization, either as members, as slaves, or as simple workers. In this sense, the second scenario is that a Type 3 civilization would not be made up of a single type of species, but would have a great variety of living beings of different races and from parts of the galaxy that would all coexist together with the same interstellar organization. For now, it isn't straightforward to determine which scenario would be the most realistic, since we have not yet encountered an extraterrestrial civilization. Information. Another essential aspect of civilizations is that as they expand, their knowledge also does. From the beginning of human history until 2010, approximately 5 exabytes of information were created, the same amount of data currently produced in a single day. As our civilization grows, so does our generation of information exponentially. A Type 3 civilization on the Kardashev scale would produce thousands of exabytes per second. Because of this, they would need to build quantum computers and other devices much more powerful than we can imagine today. Not only that, but by becoming artificial beings, they could have access to all this information instantaneously, having the reasoning of a biological being but the computing ability of a quantum computer. Control of space-time. A Type 1 civilization can control genes, alter the development of living things, and manipulate molecules. A Type 2 civilization can control subatomic particles and manipulate atomic nuclei at will. But a Type 3 civilization would be capable of all the above and could also manipulate the basic structure of space and time. Because they would have the technology to manipulate stars, they could also use the structure on which the entire universe is built. This would lead to the possibility of creating technologies that allow them to travel through the universe using machines that for now only exist in our imagination, such as the warp engine, which we already talked about in a previous video, about the technologies that extraterrestrials would use to bequeath to the Earth. With this technology, they could travel interstellar distances in fractions of time that for now are impossible to achieve in the universe. In this way, they would reach every corner of the galaxy in a few days instead of taking several thousand years. With the energy of a galaxy and the ability to manipulate space-time, such a civilization could create famous wormholes. Wormholes are hypothetical structures of which we do not yet have evidence of their existence. Still, according to theoretical physicists, to come into existence, these structures would be cracks in space that would serve as shortcuts to connect two very distant points of the universe and travel all that distance instantaneously. Although this technology only exists in movies, this kind of technology would be possible for a Type 3 civilization on the Kardashev scale. Possible examples of a Type 3 civilization. Imagining a Type 3 civilization is difficult in real life. However, in the world of science fiction, there are some attempts to capture what a society with these characteristics would be like. In Star Wars, an organization called the Galactic Empire is presented that consists of an army that has total domination over an entire galaxy, reaching members of its organization on each planet and having managed to populate all the solar systems of which they have reached. Science fiction writer Arthur C. Clarke once said, "Any sufficient advanced technology is no different from magic. This is because if a person carries modern technology to humans from 2,000 years ago, for them it would be so incomprehensible that they could not differentiate technology from magic. Members of a Type 3 civilization would have technology that would be no different from magic for us. They would be able to move stars, move solar systems, travel through space-time, manipulate black holes, and even life eternally. Rather than living beings, they would be the closest thing we can imagine to gods." Civilization Types 0, 4, and 5. When Nikolai Kardashev proposed the Kardashev scale, he only raised the 3 types of civilizations discussed throughout this series. However, other specialists decided to expand the scale of the original Kardashev a little and add another 3. Civilization Type 0. This is a civilization that is well below Type 1. This was created to place the human race within the scale. The society of humans is in Type 0 since we are not yet able to take advantage of the total energy of our planet. Civilization Type 4. Far above the Type 3 civilization that can control the energy of a galaxy is the Type 4 civilization, which consists of a society capable of handling the energy of multiple galaxies of the observable universe. Scientist Michio Kaku was the first to introduce this type of civilization within the Kardashev scale. He deduced that if there can be a civilization capable of controlling an entire galaxy, sooner or later, civilization will have the power to prevent the management of multiple galaxies of the universe itself. He also mentions that if possible, for now, there is still no such civilization, since if it existed, we would have already realized because our galaxy would be under its control. Examples of a Type 4 civilization. If a Type 3 civilization is already difficult to imagine, a Type 4 civilization is even more so. However, some writers have tried to capture what the characteristics of a Type 4 civilization would be like. The first of these examples is the Galactic Frieza Army, which is the name by which it calls itself, a fictional army that appears in the anime series Dragon Ball Z, created by Akira Toriyama. This army is commanded by the Emperor of the Frieza universe, who is one of the main enemies of the protagonists. In the animated series, it is shown that the Galactic Frieza army has managed to conquer the entire universe, and its main area of trade consists of finding habitable planets, eradicating any intelligent species that inhabit it, and then selling them to other extraterrestrial races looking for a place to settle. There is also the example of the 1965 novel Dune by writer Frank Herbert. In this novel, it is narrated that humanity has managed to populate the entire universe, although the primary outcomes happen in a single group of planets where a struggle for the power of a material that triggers an interstellar battle takes place. In both cases, it is shown that the technologies developed by both works of fiction allow them to travel throughout the universe without problems. Civilization Type 5. Finally, the Type 5 civilization can control all the energy provided, not only by the universe, but by all the universes that can exist. That is, maintain the energy of the multiverse. This last civilization falls totally within the category of fantasy, since for now we have no evidence that the other universes exist. We hope that you have been able to learn all the differences between the different types of civilizations on the Kardashev scale with this series. We might never reach a Type 7 civilization status. A Type 7 or K7 civilization would travel, transcend, and ultimately oversee or be the Omniverse, which is the collection of every single universe, multiverse, megaverse, paraverse, 11D dimension, and first realm reality. Everything is in the Omniverse, and there is only one Omniverse. In other words, such a civilization would be as closest as godly as possible. However, the achievement of a Type 7 civilization will only be the end of a very long process of technological advancement and connection with the cosmos. In contrast to a collective entity, a Type 7 would likely exist as a singular being. A Type 6 society, on the other hand, might consist of numerous individuals connected through a hive mind, allowing for universal communication and sharing of thoughts. However, this arrangement would prove insufficient for a Type 7, due to the potential for imperfections. Achieving perfection is crucial at this level. Thus, it is probable that we would encounter a single individual or essence, not as a result of deliberate choice or design, but rather as a consequence of nature. However, even comprehending the nature of this entity is a daunting task for us, as we find ourselves at a much lower level of understanding, namely level 0.73. Describing it accurately is highly limited by our current capabilities. We might even label it as a deity, but interestingly, it would also be the very reason why we conceive of gods in the first place. Not only would this possess the knowledge to answer any conceivable question, like a Type 6 civilization, but it would not even need to formulate the questions in the first place. To Type 7, the necessary information would simply exist throughout time and space, across countless variations of multiple timelines in numerous multiversal dimensions. Nothing would remain unknown or unexpected. For the Type 7, existence itself would be effortless. What if humanity lived in a reverse Kardashev scale? While the Kardashev scale offers considerable food for thought, it is not without its problems. First and foremost, and stating the obvious, no empirical evidence exists indicating the presence of K2 or K3 civilizations in our galaxy and/or galactic neighborhood. In fact, the Fermi paradox, once been dubbed the Great Silence, would indicate that civilizations never become migratory, thus making a Type 3 very unlikely. If Kardashev civilizations exist, we should expect to see large swaths of neighboring galaxies disappear from the visual spectrum, yet we don't. And we haven't found any Dyson spheres either, although that doesn't mean they don't exist. Another problem with the Kardashev scale is the assumption that advanced civilizations have an insatiable appetite for energy, and that they inevitably want to expand into space, when perhaps turning a galaxy into a huge supercomputer is the last thing an advanced civilization would want to do. At the end of the day, what do we know? Alien intelligence may have other desires and goals that don't involve this kind of intergalactic imperialism. It must have been similar reasoning that brought cosmologist John Barrow, unfortunately passed away in 2020, as did Kardashev himself, died in 2019, came up with his own alternative system, the scale of micro-dimensional mastery, or the microscale. Barrow's inversion of the Kardashev scale proposes that it's how well a civilization can control small things like atoms and quarks that really counts, rather than how well it controls large things like stars and galaxies. For Barrow, the more you can master the minuscule, the more advanced you can become. Barrow's scale features a Kardashev-like ranking system, only it moves the other way, getting smaller and smaller as the levels increase, and humans are already a reasonable distance along with it. A Type 1- is any civilization with the ability to use observable raw materials in construction, which covers a range of things that humans can already do, from building a house to baking a cake. A Type 2- is capable of manipulating the cells and organs of the body, as well as genes, which humans can also already do through gene editing technology. Type 3- is where we begin to reach our current limit though, because humans lie somewhere between here and Type 4- without quite fitting into either category. Type 3- manipulates molecules to create new ones, which we can already do to a certain extent through chemical engineering, including the creation of plastics and synthetic polymers. But we haven't yet mastered this as thoroughly as we have the previous levels, and our synthesized materials still leave a lot to be desired. Meanwhile, the hallmark of a Type 4- is the full mastery of atoms and nanotechnology. Again, we have made some progress here, for better or worse, and take just a cursory glance at any 21st century tech news outlet, and you'll see that nanotech is widely pitched as the next big thing for humankind, but we still have a long way to go until we totally understand it. Barrow's scale then extends to Types 5 and 6-, before reaching its micro-pinnacle with Type Omega-, which is the ability to manipulate space-time itself. An Omega civilization would have the very fabric of reality under its spell, but suffice to say, humanity is nowhere near this just yet. For now, we're all too busy getting to grips with Types 3 and 4, with the mastery of molecules and atoms. But what should our civilization be like to be defined as a Type 4-? As mentioned, nanotechnology is the primary goal if humanity ever wants to call itself Type 4-. There are now thousands of nanotech products available, including nanoparticles designed to improve cosmetics, antibacterial cleaners, clothing, fuel, and to provide an edge with sports equipment. But this is first-generation nanotechnology, and we expect far greater things in the future, and to wield far greater control. If humanity was Type 4-, then it would probably have at its disposal a machine called a molecular assembler. This is a theoretical device, most championed by the US engineer Kim Eric Drexler, which would allow its user to specifically move and place individual atoms to precisely form brand new molecules and kickstart controlled chemical reactions. With a molecular assembler, life would be like a jigsaw puzzle made up of infinite pieces and guided by our hands. Strength reinforcement would be top of the list of things we'd hope to achieve with it. The idea is that we could make all existing products stronger, faster, better, and less likely to go wrong or depreciate. As an example, imagine reorganizing the atoms in graphite to engineer a diamond. The value of diamonds would probably go down, but only because so many more things would be made of this famously robust ingredient. Nanotechnology could give us greater control over our own bodies, too. The prospect of medicinal nanobots has made the headlines time and time again in recent years. The theory is that these invisible machines will be able to enter into a person's body for precise medical treatment. They could target cancerous cells and destroy them without the need for chemotherapy or invasive surgery. They could be used to improve the strength and function of our bones and muscles, or if modeled after red blood cells, could be used to deliver oxygen all around the body. For a Type 4- being, nanomedicines are designed to increase longevity and quality of life. So is there a downside to all of this technological improvement? Well, some worry that for all the problems it solves, nanotech could create new ones as well. Unfortunately, lots of nanoparticles, including those found in cosmetics, double up as pollutants. They may be unseen, but they can clog up our world, which is why environmental agencies want more research done into them and greater regulation. Were a Type 4- society to take off in a big way, then it would need to first know that the tech driving its progress wasn't going to have long-lasting negative effects, or else it could wind up destroying itself. And according to one particular theory, that there is no over-exaggeration. The gray goo catastrophe is a doomsday scenario like no other. First proposed again by Drexler, it's a potential apocalypse where humans lose control of nanotechnology, particularly if it becomes self-replicating, leaving the tiny machines to ruthlessly devour everything in their path. Eventually, Earth and potentially the entire universe is transformed into a homogeneous mass, the gray goo. The good news is that most scientists who work with nanobots insist that this isn't what's going to happen. Clearly, at our current level, we still have a lot to learn, but there's also an all-new world on the horizon. And that's what would happen if humanity was a Type 4- civilization. What do you think? Is there anything we missed? Let us know in the comments.